Okay, hello and welcome. This is going to be the first video in our video series on pre-calculus. We're going to start as an introduction talking about circles and the equations of circles and how to use them. So we'll start with working with the standard form of the equation of a circle. So in class, we spent a little bit of time deriving some of these and showing where they come from. In general, we can define a circle as the set of all points in the xy plane that are a fixed distance, which we call the radius, from a fixed point. So a circle relates all points that are the same distance away from some central point. So we call that the radius in the center. Those are the two main attributes of a circle that we'll work with. And then in class, we also showed one particular circle called the unit circle that has this formula: x squared plus y squared equals 1. That's a circle centered at the origin with a radius of 1. And if you recall from pre-cal, the unit circle plays a big role in trigonometry. And if you don't remember, we'll be going through that material again in this course as well. Then we looked at something more general, so the equation of a circle of some radius instead of the fixed radius of 1. We could just make it more generalized, just say some radius r. So x squared plus y squared equals r squared. And if you recall, these are basically just coming from the Pythagorean theorem. From the hypotenuse of a right triangle can be described as c squared equals a squared plus b squared. We just made it more abstract, and we're using it to define circles. But you see that general form: something squared plus something squared equals something else squared. That's a Pythagorean form. And then the most general we can get to is what we're calling the standard form of an equation of a circle, where now we can choose any center point. The center is the point h comma k, and the radius is r. So this statement, x minus h squared plus y minus k squared equals r squared, will describe any circle in the xy plane with a center point and a radius. So let's use this to describe some circles and see some examples. So this first example is asking us to write the standard form of the equation of a circle with radius 5 and center -3, 6. So let me write the standard form again. It's x minus h squared plus y minus k squared equals r squared. So what do we have? We have a radius of 5, and we have a center at -3, +6. So the -3 is our h, and the +6 is our k. So we really just need to plug these in. But notice in the form, we have these minuses, and just have to be careful. So when I plug this in, my h is -3, so this would be x minus -3. It's actually going to turn it into a +3. And then since k is +6, we can say y minus 6 squared. This will equal r squared. Our r is 5, so that would be 5 squared. So let's just clean it up. Let's get rid of the double negative. X minus -3 will turn into x plus 3. And we have y minus 6, and then 5 squared is 25. And that'll be our equation. So if you're given a center and a radius, you can define the full equation of the circle using the standard form. So one thing to notice that I want to point out is when you're looking at a circle in standard form, you can read the center and the radius, but you need to keep two things in mind. The first is that the signs are flipped for the center point. We know our center point is -3, +6. And notice in the formula, it's shown as a +3 and a -6. So the signs flip because of this minus. So it's tempting to look at this and say, oh, the center is at the point 3, -6, but that would be incorrect. That would be a different circle. And then the second thing just to keep in mind is that this number here is not the radius, but this is the radius squared. The radius squared is 25, so therefore our actual radius should be just +5. So just two things to keep in mind. All right, now let's think about producing the graph of a circle given an equation in standard form. So we have x plus 3, let me write it out again here, x plus 3 squared plus y minus 2 squared equals 16. So keeping in mind what we just talked about, our center will not be at +3, -2, but the flipped sign version of that. It'll be at -3, +2. And then our radius, well, r squared is 16. So r should be technically plus or minus 4, the square root of 16. But since this is technically an application, we're thinking about a circle and typically think about distances as being positive. So we'll take the positive version of this. So we'll say our radius is 4. So that's enough to produce the graph of our circle. So you just want to plot the center point. So at -3, +2. The center point isn't a point on the circle, but so I'll end up erasing that later, but just a good point of reference. And then since the radius is 4, I can go out a distance of 4 in each direction. I know this should be a distance of 4. You can go 4 units to the left. 3, 4, 4 units below, and 4 units to the right. So I kind of set up some points that I know will be on the circle, and then I can try to fill in the rest. It's hard to get a perfect circle. Let me try this again. Okay, that'll be good enough. So the next example asks us to think about some other points that would be on the circle. It's asking us to find the intercepts, if any, on the graph of the circle. And notice this is the same one that we just graphed. So visually looking at this, we know we should be expecting, it looks like 1, 2. It has 2 x-intercepts and 2 y-intercepts. And so how do we find those? Well, just think about where do intercepts occur? The x-intercepts occur when the y value is 0. This has some x point, which we need to find out, but the y point of that coordinate would be 0. So if we want to find the x-intercepts, just set y equal to 0. So I can say when y equals 0, and I'll just replace the y with a 0 in our equation. So we have x plus 3 squared. Instead of y, I'll write 0 equal to 16. So now we just need to solve for x. We have only one variable, so we can solve for it. So I still have x plus 3 squared. 0 minus 2 is negative 2. So negative 2 squared. Negative 2 squared is positive 4. So I'll subtract the 4 over. Get 12. We'll need to take the square root of both sides. And so recall when you do that, you need to introduce a plus or minus. And that's what's going to produce our two different points. So I'll subtract 3 over. Now we could type one of these into a calculator and get some decimal, but I like to try to keep things as exact as often as I can. One thing I would want to do is reduce that square root of 12. So what would it reduce to? So I just want to remember reducing square roots. If I have the square root of 12, well, I can think of that as the square root of 4 times 3, trying to break it into factors where one of them is a perfect square. So like 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. I'm trying to find some of these numbers, or trying to break this number up using some kind of perfect square number, because then I can take the square root of that. So I know 12 is 4 times 3, and I know the square root of 4 is 2. So that means that the 4 can come out as a 2, and I have the 3 left over inside. So root 12 will reduce to 2 root 3. So that's what I'll use. So when y equals 0, we get x is equal to negative 3 plus or minus 2 root 3. So what would be those intercepts as points? Well, one x value would be negative 3 plus 2 root 3. And then the y value would be 0. We got that x value by plugging in 0 for y. And then our second one would be negative 3 minus 2 root 3. So that plus or minus gives us 2 points. And that's what we're seeing here. So we have negative 3 in this distance, either to the left or the right of our center point, is a distance of 2 root 3. So those are our two x-intercepts. So let's find the y-intercepts in the same way. We can find y-intercepts. They will occur along the x-axis, and that's when, or along the y-axis, I'm sorry, and that's when x is equal to 0. So we just need to plug in 0 for x. I can say when x equals 0. So I got 0 plus 3 squared plus y minus 2 squared equals 16. So now let's just solve for y. 0 plus 3 is 3. 3 squared is 9. So 9 plus y minus 2 squared equals 16. I'll subtract the 9 over. (16 minus 9 is 7). Now, when doing this, you might be tempted to multiply out this y minus 2, like to FOIL it out. But since it's already factored like this, you want to just hang on to it and move everything over to the other side. And then you can just take the square root of both sides. If we were to multiply it out, we would end up having to factor again. We'd be going backwards. So I'll take the square root. So y minus 2 equals plus or minus square root of 7. And again, the plus or minus is what's going to produce our two different values. So I'll move the 2 over, 2 plus or minus root 7. Square root of 7 won't reduce to anything. 7's prime. Its only factor is 1 in itself. Neither of those are perfect squares, so we'll just leave it at that. But let's describe it as points. We were saying x is 0, so our first y point would be 2 plus root 7. And then our second one would be 0, 2 minus root 7. So these will be our 4 intercepts. These two are our x-intercepts, and these two are our y-intercepts. All right, the last thing that this section will cover is another form of the equation of a circle called the general form, and it looks a bit more complex. If x squared plus y squared plus ax plus by plus c, where a, b, and c are just some numbers. There's some coefficients of x and y, and then some other constant here. In our previous versions, so say like x plus 3 squared plus y minus 2 squared, if we were to multiply this all out, if we were to FOIL out x plus 3 squared and FOIL out y minus 2 squared, it would be, and clean up our anything that we can combine together, we would get this general form. So it's like or you could say the standard form is the factored version of the general form. So that means there is a way to convert a circle in general form to standard form. And that involves the process of completing the square, which hopefully you can recall maybe from college algebra or some previous algebra class. So let's take a look, and I'll remind us of the process. So we have x squared plus y squared plus 4x minus 6y plus 12 equals 0. So the first thing I'm going to do is just group my x's and my y's together. That just helps me visually. I'm going to have x squared plus 4x. I'm going to leave a little space because if you remember in completing the square, we're going to add something to each of these. So I'm going to leave a little space, and I'll say plus y squared minus 6y. And then one of the first things I do is move this constant number over to the other side. So I'm going to subtract that 12 from both sides, so it will appear as a negative 12 on the right side. Oops, and I wanted to leave a little space here too, so let me do that. Okay, so with completing the square, we want to find some number that when we add at the end here, it will produce something that factors into a perfect square. Oops, something that will factor into, we'll be able to turn it into something squared. And then here we'll get something else squared. And notice it's starting to look like that Pythagorean form, something squared plus something squared. This will be something squared on the right as well. So how do we do that? So if you remember with completing the square, to produce this number that we're going to add, you look at this middle term, often called the b term in standard quadratic form. So you take that term, so let's say 4, I'm going to do this on the side. The process is to take this number, divide it by 2, and then square it. So in general, if we have some partial quadratic, and here we don't have an a term, so, but in general, we have like ax squared plus bx plus c. You may have recalled this form. We're just looking at something like x squared plus bx, squared variable plus the same variable to the first power with some coefficient. So it's that number that we're taking. This is the b term here. So we take that number, divide it by 2. You always divide it by 2 this is just kind of part of the process. We're not getting that 2 from anywhere in the particular problem. So take the number, divide it by 2, and square it. So 4 divided by 2 is 2, and then 2 squared is 4. So this is the number that I will want to add here. So I'll say plus 4, but we're adding something to one side of an equation, so I need to add it to the other side as well. Make some room here. So let's do the same thing for y. In this case, our b term is -6. You want to use the negative as well. If there's a minus, you would bring that with you as a negative. So take this number, divide it by 2, and then square it. -6 divided by 2 is -3. -3 squared is +9. So that's the number I want to add over here. And then again, you have to add it also to the other side of the equation. So now look what this will do for us. It ends up producing 2 perfect square trinomials. If we were to factor this, thinking, doing a standard factoring method, you would look at this last term, factors of 4 that add up to my middle term. Well, that happens to be 2 and 2, meaning that this will factor into x plus 2 times x plus 2. Similarly for our y's, factors of 9 that add up to -6, well, that's -3 and -3. -3 times -3 is +9, and then -3 plus -3 is -6. So we get y minus 3 and y minus 3. So since these are both the same factor, we could just write it as x plus 2 squared plus y minus 3 squared. But let's not forget about the right side as well. So we have -12 plus 4 plus 9. That looks like -12 plus 13, so that should reduce down to a +1. So that means we have x plus 2 squared, because we had 2 of those same factors, plus y minus 3 squared equals 1. And then look at that, we have an equation of a circle in standard form. Now just by looking at it, we can read the properties off of it. We know, okay, this is a circle, it has a center at -2, +3. Remember, the coordinates will flip in sign. And then our radius will just be 1, because we could say r squared equals 1. Well, the square root of 1 is still 1. So with that in mind, we can create a quick sketch of our circle. -2, +3, that would be our center point. Then we would just go a distance of 1 unit in each direction, so it'll be a little circle over there in the second quadrant. So again, the general process, if you have an equation in general form and you want to convert it to standard form, because then it's really easy to tell what it should look like, where it should exist in the xy plane, the general process is to complete the square on both sides. Or I mean on both variables, on both x and y. All right, so this was a short section. We were looking at section 1.4 on circles. So we wrote the standard form of the equation of a circle. We graphed circles, and then we worked with the general form and converted it back to the standard form. Moving forward, we're going to return to some more fundamental topics on functions, but I think this is a good introduction to the course. One, just to get a bit of a refresher in our headspace back to algebra. If you're coming from trig, you've been thinking about trigonometry for a while. So thinking about like factoring, working with square roots, solving equations, but also it starts to get us thinking about like mathematical modeling, thinking about functions as models of behavior, um, and thinking a little bit more deeply and a bit more generally about mathematics. So I think it's a good introduction. Okay, we'll stop for there, and I'll see you next time.